Okay, mentally math.
Let's get mental.
You sound a little tired today.
I fell down like buckets.
Okay. Alright, let's see. Have it so you can see it. Yes! Lesson 55, average and rate problems with multiple steps. It's a lot of steps that are all very simple, though. Anyway, we'll get to that.
Wait, are you teaching about reflections and transformations?
Nope, that's not today's lesson. But I do look forward to that so that I can talk in a mad scientist voice about transformations. But no, today we're doing average and rate problems with multiple steps.
That sounds interesting.
It's straightforward, but there are indeed a lot of steps. So I'm sure you're doing these right now.
Mr. Patrick?
Mm-hmm.
C is actually almost the exact same as yesterday.
Yep, except...
plus 5.
Yep, exactly.
Wait, what's the difference?
Good memory. Yesterday's was plus 5.
Oh.
So actually, this one's simpler today.
Yeah, it's not. It's very. I remember doing this. Well, it's really the same difficulty, I think. So, Mr. Frederick, could I move to one which is not used desk?
You can move to any empty desk where you can see better. Yeah, well, sorry, your seating arrangement isn't that great this time around.
Monday anyways.
Maybe not Monday, but yeah,
The Monday after?
because yeah, that sort of thing. Okay, so I'll assume people are a couple out ahead of me by now.
Mr. Frederick?
Yes.
The answer to E is quite relevant to the question.
Okay.
What do you mean?
All right. So number A, problem A, letter A is we just can say 50 cents times 10
Mr. Frederick?
for $5.
I just realized something I could do for E and I didn't do it.
Oh, okay. Well, I'm sure it'll all work out okay in the end. Then we're timesing this, multiplying this by 100. So 2 boingies, boingy, boingy. 37 and 5/10.
There's no estimation.
Yep. So nothing to trip people up today. That's always fun though. All right. So for this one, I add 5 to each side. So then it's just 80 divided by 2. So x equals 40. Then metric conversions. There's 1,000 meters in a kilometer, so it's just 3 kilometers.
Oh my god, that is so sexy.
Easy peasy lemon squeezy.
That was so hard. Mr. Frederick, like, oh my god.
All right, so 2 times 2 is 4. 3 times 3 is 9. Da-da.
I just realized
Then
I could just square the numerator and the denominator and then put those in and it would be the same thing.
I think of letter F as just there's 3/4 out of $1, 75 cents.
Letter F, I think, could be in like third grade.
Oh yeah, totally. And G. 1 quart. 1 quart. What does that sound like? Sounds like a quarter. 1 quarter, which 1/4 is the same as 1/4.
Third grade mental math again.
Okay. And then I don't think they do fractions in first grade. Then this one seems just really surprisingly simple for being a letter H. So it's 2 times 30 is 60, then plus 15 would be 75.
We're not doing estimation anymore.
Da-da.
Yeah, I like to see smart score.
Okay. So I might try to go through these first 2 sort of quickly because they are quite simple and we're just applying the concept to the next examples. So the average of 3 numbers is 17. What is their sum? Well, if the average of them is 17, then what are a couple of combinations that would work for this?
Yeah. 10 plus 4 plus 3?
No. Average.
Oh,
The average, so there's 3 numbers, and if you average them, it'll be 17.
Yeah.
Okay.
It is pretty mentally mathy.
Okay, this might be a bad thing to do. 17 plus 17 plus 17.
There you go. That is one of the answers.
Can't you just multiply 17
Yes.
times 3?
Well, multiplication is repeated division. Or multiplication is repeated addition. Excuse me.
I have one too.
So yeah, you could just work with that idea right there. Is if it says what is the sum of all the numbers when the average is blah blah blah, and you know how many numbers you are, you just multiply that number by the number of numbers you have.
And then it just be also.
So simply, you're fine just solving this like this. I mean,
16 plus 8.
yes. You could have the numbers be this. That's possible, sure. But as far as answering their question of what is their sum, all you need to do is multiply it. So just remember for that. So we're done. We probably shouldn't spend too much time on this.
One that you could do is 1, 17, and 33, right?
You could come up with some different things, but in terms of answering their question, you just need to multiply by the number of numbers in the average, and you're good. And we will be using that moving forward. So the average of 4 numbers is 25. So if 3 of the numbers, we know 3 of the numbers are 16, 26, and 30, then how do we do what's the 4th number? What do you think?
You first do 25 times 4.
Oh, okay. You could do that first, just to get something. So yeah, you could do 25 times 4 because we're gonna get the total.
Mr. Patrick, could you just
Okay.
25 plus 3?
25 times 4 is how you could do that. So now you know what the sum of everything that's being averaged is, and then what would be our next step?
Well, we
Yeah.
could add 6. We could add yeah, we could add 16,
Mhm.
26,
Mhm.
and 30.
Yep.
Oh, I just mined
72.
Okay.
them directly.
Right. And then
From 100.
there we go. Good job, people.
Is it fine
I'll owe you a focus point.
Mr. Patrick, is it fine if I just minus directly?
Well, did it get you to the correct answer?
Yeah.
Okay. Yeah, the answer to how to get this is in whatever order. You should add up the numbers that you have, figure out what your total sum of all the numbers are, and subtract the ones that you've got from that. And if you added these up first, then did that, that's perfectly fine too. Okay, so taking this to the next level. After 4 years, the average number of students participating in after-school sports was 89. How many students must participate in the 5th year to bring the average up to 90? So, what could be my first step in figuring this one out? Ooh. People looking a little bit bamboozled. Okay, well, it's not that different. It's not that different than this one, really. So what are the steps that we did with that? So I see a hand raised here. Oh, I probably couldn't see your hand raised, but let me see what you have to say. Yeah.
89 times 4,
Okay.
and then you get that.
So that is something you will use, and
then you do 90 times. You would do 90 times 5.
mhm.
And then you would minus that answer by the answer of 89 times 4.
Right, and so then you would.
Do 450 minus 356.
Okay, well, it sounds like you've already been busy. Yeah. So here, here. So gonna do these out.
And you get and then you get 94 students.
Yeah, and I'll have a handy visual for what's going on here. So, well, why don't we see how this will work? So, I'm doing this 4 times 2, 32, so 35. Ooh, dude. All right, then 450.
Wait, it is 10. No,
Okay, it's all right. It's all right. We all have little moments like that. It's okay. Okay, so I know I do. I'm not judging anyone here. Okay, so yeah, so it would need to be 94. We're correct. So let's see what's going on here, or how we could think of this. So.
we can get the actual values.
So say 89, 89, 89, 89, and then 94, right? So you could think of it like this. We could think of it like we're now, of course, these would all need to be the same if we're thinking in terms of the average, as in 90 times.
It's perfectly fixed.
Right. So yeah, it totally fits because you could think of it as we could subtract. Maybe I'll switch to a different color. We could subtract 4 from this one, which would make it 90, and then take one of each of those 4 and add it to that, which would make them all 90, right? See what I did there? Okay. So why don't you give me 1, 2, or 3 about how you feel about this? Okay. I'll take 2.5s right now. I'll even take 2s. Okay. All right. And, oh no, not 10. You'll break the fabric of the universe with 10. Huh? Okay. All right. Okay. It seems like people are pretty okay with this, and we'll be practicing. This is totally the type of question that can end up on the CTP. But actually, this one will most definitely be on the CTP. Like you remember when we started doing these unit ones where it just stopped with saying, what would be the unit price per ounce of something if the total price is this, and I said, oh yeah, well, we're just learning this right now because we'll end up using it to compare 2 different brands that are 2 different, amounts of ounces at different prices, but you need to check to see which one is the better price per ounce. This is that problem, and you need to know how to do this problem. It's really simple. It's super simple, as long as you know how to get the unit price. So Tyrone is buying refreshments for the. I know he's got a cool name, right? Tyrone. I totally want to hang out with someone named Tyrone. For the next math club meeting, brand A cranberry juice is on sale at $3.20. For a 64 fluid ounce bottle. Brand B costs $1.19 for a 17 fluid ounce bottle. Which brand is the better buy? Well, the thing is, I'm just gonna give a brief explanation and ask for people to try to solve it themselves. Is you just need to get the unit price for each one per ounce, and you do that. So say we're talking about brand A, you do that by saying, okay, I've got 64 ounces. It's going to cost $3.20. So how much would the unit price of 1 ounce be? And then you do the same thing for brand B. So I'm just going to let people do it. I don't see any reason why anyone wouldn't be able to do this. So I'm just going to sit back and let you get out ahead of me.
For some reason,
I
one of
have
them
no
looks like
idea what I'm doing.
Huh?
I have no idea what I'm doing.
Well, look, I just put it up on the board.
Mr.
You're
Brand.
figuring out how much it costs per ounce by saying, okay, well, what's $3.20 divided by 64?
I'm trying to find the LCM for some reason.
Well, you don't need to do anything like that. I'm spoon feeding this to you. So, was there a question or? Yeah, I'm giving this to you right here, and then you just do it for brand B as well. It's just simple division to get the unit of each one. So finding the unit just generally means you're dividing the two numbers. In this case, what you're trying to find out is the price of one thing. So you're dividing it by how many things you have by the total. Or I should say, yeah. Should have said that the other way around. You're dividing the total by the total number of things you have to figure out how much one of those things costs. So I can think, okay, there's no 64s in 3, and there's no 64s in 32. But I do know that 64 times 10 is 640. And I do know that 320 is half of 640. So that has to be 5. So that one's going to be 5 cents. So now for brand B, we do the exact same thing for the 17-ounce bottle. So I bring up my decimal, and I can go, okay, there's 0.17s in 1, and there's also 0.17s in 11. And then a little guesstimation. 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 I could say, well, it's not 10 times as much. It's more than half as much. So it's probably 7 or 8. Seems a little low. We'll try. Oh, and also, oh, hey, 7 times 7 is 49. So that is kind of a giveaway, isn't it? Uh-huh.
I actually did it by multiplying 5 by 17.
Uh-huh.
And then compared it to $1.
Okay. Well,
I
got
just knew that 5
0.5
times
and
20 is 100.
0.7.
that is correct. 0. Oh, well.
I didn't have that.
0. Well, oh, what you did? You did that?
No, I just did 0.5. I didn't even add the 0 before the.
Well, if you're looking at the division problem, how many 64s are there in 32? Answer is none. Half of one. You could think of it. So, gotta keep. No, the pizza paradox does not apply to this one. Okay, so everybody, which one's the better price? It's brand A. So, okay, let me see. Give me a 1, 2, or 3 on this one. How are we feeling?
Good job, Daryl.
Okay, all right. Okay, great. Because you definitely need to know this because this will come up. It's a really basic test of your mathematical acumen. Now this one, okay, so I'm not going to get too much into the tyranny of making 8 $8.10 an hour or $9 per hour and working a full week on that. But what we have here are a series of steps. All of the steps are very simple. There's just a lot of them. So Brenda has 2 part-time jobs. During 1 week, she worked for 20 hours at the bookstore for $8.10 per hour. Yeah, oh, go ahead. Yeah, I'm giving you time to do this faster than me. Uh-huh.
So, is she working as a receptionist at the bookstore? Because, like...
No.
Good.
It's 2 different jobs.
Oh, okay, so then we don't have to add those values.
Well,
I mean, for A, we don't have to add the values, right? Because she's not working.
well, look at what all the problems are asking. So, she works at the bookstore for $8.10 per hour. And she worked 20 hours at $8.10 per hour. And she worked for 16 hours the same week as a receptionist at a different place for $9 per hour.
What's a receptionist?
Oh, it's like someone who answers the phone and is at the desk if someone like walks into the door and says, "Hi,
I want money.
I'm here for business purposes," and the receptionist says, "Oh, do you have an appointment?"
I'm a kid.
Okay, so that should have given you plenty of time to figure out how much did Brenda earn at the bookstore. So it's just some simple multiplication. So she worked for 20 hours. So you know what? I think I might Saxonize this a little bit. Yeah, Saxonizing this. So I'm going to use their particular. Now I know we multiply these, and they don't say to use unit multipliers. So I'm not holding you to that, but I'm gonna show you what the way Saxon presents it here. So I'm thinking 20 hours times the rate of $8.10 per hour. And so what we want to end up with here at the end is money and no hours. So you can think of it as the imaginary /1 underneath. Cancel your hours, leaving you with 20 times 810, which is basically 81 times 2, which is $162. I think he's being a bit sarcastic. Okay, then same thing for the other one. So how much does she earn as a receptionist? So this time we're talking about 16 hours.
She should work 20 hours as the receptionist.
Okay, yeah, she's an imaginary person. This is an imaginary scenario. Just teach us math.
Mr. Patrick,
Mm-hmm.
do we have to do this, the unit multiplier?
Nope, it doesn't say you have to. I'm just Saxonizing over here.
So if it says you have to, then you should.
Yes.
Otherwise, you can do whatever you want.
That's as far as I'm concerned, but I am here to teach you Saxon math, so I'm going to show it the way the book is trying to show it. Okay. So looking at this, I can cancel off my hours, and then I can think of this as 90 plus 54, right? Using a little mental math. So that would be 144. And then for C, I'm going to put my C right here. You want me to put my C right there? Why am I put my C right here? Yep, because I just add them together for C. What were her total earnings for the week? And really, these zeros at the end are sort of silly, but okay. And so then 6. $306.
Is that good?
No, that's terrible. But we're not gonna go off too much on that, on the unfairness of Brenda's situation, huh?
I didn't understand B.
Right. Well, this is where it starts to get a little more tricky here. So, what was her average rate of pay for the week? So what it's asking is how much did she make per hour? What was the average amount she made per hour?
It made it confusing.
Oh, okay. Average rate of pay. Yeah, rate of pay are these things. So $8.10 an hour, $9 an hour. That is rate of pay. So if they say rate of pay, they're asking how much like an hour.
They literally just said the answer.
So then, no one said the answer. So 306. I'm not gonna add the zeros at the end like the book did. And 36 hours. And so it would be equal to. So guess what I need to do with these two numbers? Divide!
It's gonna be a
Where'd you get the 36 from?
36 hours.
Okay.
20 hours plus 16 hours.
Oh,
What am I doing there? Okay, oh, I see. Okay, so 306. I guess I'll put my zeros there. 36. Excuse me. Sorry.
Yeah, exactly.
Sorry. Okay, so once again, there are no 36s in 3. There are no 36s in 30. Oh, gotta bring my decimal up here. But so in 306, that's.
We had a 0 after it.
Huh?
I thought we had a 0 after the decimal.
We're getting there. I'm just putting this decimal up for now.
Oh.
Okay, so 306. It's kind of close to 10 times as much, but I don't think it's quite 9 times. So we'll say 8 times. Right. So 8 times is 38. There's 4. So this is 24. Plus this is 28. Okay, I'm going to turn that into a 29 there. Getting me to that. Oh, okay. Then I'm going to bring down my 1. Bring down my 0. And I can think that, hey, 18 is half of 36.
So that's just 5.
So, yeah. Okay.
$8.50.
And then that will work. I can just add my 0 at the end since we are talking about money. And so our answer would be her average rate of pay would be $8.50 for 1 hour. So, as you get, yes. Like I said, we're not going to talk too much of the tyranny of Brenda's situation here. Okay, but I mean, it's a lot, but they're all simple steps.
Yeah.
But there are a lot of them, so it's like, don't get too overwhelmed by the fact. It's just go step by step and figure out what you need to do at each step to fulfill the requirement, and then you use information that you got from a previous step to solve the next step, kind of thing.
So, I thought you said Brenda's pay was a lot.
Oh, no, I did not say that.
That's what you said.
That was not what I said. Okay, alright, then that's it for lesson 15.